We have sound? Good. All right. I think I have everything this time. All right, let's get started. So, someone just pointed out to me that there's some inconsistencies between what's on the home page and what's on the week-by-week page, so I know what my work is going to be, is to try and fix them so they actually are coherent again. At risk with moving anything around, especially when you have it in multiple places. How many of you actually have an idea for what you want to do for capstone yet? Cool. How many of you who haven't picked a capstone yet have looked at the examples? Okay, cool. I mean, if you want something really dark, I've got a really dark one to build too, which is great because you make a lot of money out of it. I mean, if you wanted to be a multi-millionaire, you might not be able to live in Canada any longer, but that's a different matter. So it's kind of hard to tell the difference between building a test platform for displaying investment portfolios and building a scam website. Essentially the same thing. But the scam website, I think, pays better. You just have to live in Southeast Asia. I wish I could say I was joking. Last term, I actually taught this whole example of what are called pig butchering operations, and how you can actually take the specs required to build what is in essence a big factory for running scams, and you can't tell it apart from a lot of the things you will build for legitimate corporate enterprises. Kind of one of those nebulous sorts of areas. Because from an IT perspective, they're indistinguishable. They're difficult to tell apart. And that's beyond the dark patterns lab that we did. But so like I said, if you're looking for something like really nefarious, what's interesting is it's causing a lot of problems because last term they actually were cracking down really significantly on these, and now it's causing quite a bit of unrest. Lots of people wandering around who've been kicked out of these camps because they were basically kidnapped and made to do this stuff. Thank God that doesn't happen in the real world, right? So if you're still looking for capstone ideas, or you're having you're not sure what to do, reach out. I have office hours. I think there's somebody who has the office hours for this class today at this time, and I needed to follow up, and I don't think I did that. Because obviously it doesn't do much good to have office hours while you're in class, although maybe you'd enjoy that more, I don't know. Anybody want to share their idea? Their capstone idea? Anybody looking for people to work with them? What's your idea? Pitch it.
So I recently was looking into web security, and I found out that the most common Java Web Token abstraction.
JWTs?
Yeah, JWTs. If you take it out of the library packet, there's specifically 3 things that are wrong with it. So I wanted to build something that secures the structure of the web tokens and build a small API and host it on the cloud.
Oh, interesting. And what problem would you be solving?
I would be solving first the most simple one is missing claim validation and embedded key injection. And sometimes if you send the web token, there's a field called ALG. I don't know what that means, but if you set it to none, sometimes it can accept it if you're using out of the box.
ALG was probably algorithm.
Yeah.
So it basically says no algorithm, and then people are like, hey, cool, no problem. We'll just simply take your token to mean whatever it is you want it to mean. That's security by leaving the keys of your car in the car with the door unlocked, right? That's kind of like where my parents live, because it's too much hassle to take the keys out and there's nobody around who's going to steal the car. There's places in Canada you can go that are like that, although my parents are in California, so. Anybody else? If you want a chance to pitch your project, let me know. I'll give you a slot. You can pitch it. So we're moving into this phase now where I want you thinking about those capstone projects, specifically because they help you drive the learning process now. We're talking about these things. We're talking about virtualization and serverless and containers, and today we're going to talk about IAM. What does IAM mean? That was a long list of videos that nobody watched, I bet. Did anybody watch any of the videos? They're not that bad. I mean, none of them are horrible. I tried very much to sample across the space because I don't want you to walk in here and say, oh, well, everything is AWS because all you gave me was AWS videos. I tried to make sure you get some variety there. And you're going to watch them like at double speed anyway while you're doing 3 other things. So, am I wrong? No, right. I mean, I know how people watch these kinds of videos. I can't watch videos like that either. It's like, oh my God, this is going to put me to sleep. So you do something else at the same time. Do you have a capstone idea?
Sorry, what idea?
Do you have a capstone project idea yet?
We were actually brainstorming on the way here.
Awesome. So give us a brainstorm.
Yeah?
Sure.
But what if it's a very attractive idea and it gets taken?
That's a risk. But it won't make any difference because 2 people in here could do exactly the same project and it won't be the same.
Okay.
Unless they're working together. And then it still probably won't be the same, but that's...
Fair enough. So we're thinking of a software, because we both work in the construction industry. So we're thinking of maybe like a planning software. Still, the idea is not very clear, but it could be in the format of maybe like a chatbot or like a smart form to ask you certain questions about your project, and it can compare to similar projects in the area that have been done previously, and it could give you maybe 3 scenarios of schedules, like an aggressive schedule or a realistic schedule or a very achievable schedule.
Aggressive, realistic, or achievable?
Yeah.
Great. Sounds like software.
Yeah. That's one. The other angle we're thinking about it is maybe just an estimating, just because there's a bit more nuance that goes into scheduling, but maybe forecasting a cost for a construction schedule is a bit more straightforward.
Mm-hmm.
So,
What makes it cloud related?
what makes it cloud related?
Mm-hmm.
I'm sure we can find
There's a convincing argument.
yeah.
Okay.
We still
Interesting.
gotta think about that, but I'm sure we can find some.
I mean, as you started describing it, I was sitting there thinking, I wonder if you've tried Claudebot yet. Anybody tried Claudebot yet? Anybody read about Claudebot or seen anything about Claudebot? Yeah, basically it's here to save you from yourself. Apparently you can no longer get Mac Minis because people are buying Mac Minis and setting them up as Claudebots. Because you can do that for relatively cheap, and then you get this machine that you can stick on the internet, and it will basically run your schedule for you, and you can communicate with it, and you can have it do things, and it's like a little scary. And it ties in today's conversation because today's conversation is about IAM, which is what?
Identity access management.
There we go. He knows the words at least. What does that actually mean?
It's basically, say I come and I work for you. You get to fully decide what I can access, what I can not access, what I can change, what I can read and write, what I can from the day that I'm onboarded to the day that I get let go, or I just quit.
Or you buy the company, or right, whatever. Fair enough. Okay, so can you think of an example of something that you have to do when you're engaging or interacting with IAM? You've probably done it at least twice today.
Login.
Yeah, there you go. Here, enter your password. Show me your face. Give me your fingerprint. I'm sorry, but your DNA doesn't match the owner, right? Probably too old, but there was a movie about using DNA as a form of IAM, Gattaca, which was a science fiction movie, and it was literally about how people were stratified in society based upon their DNA. So you had to be perfect. Doesn't sound very different than what we have now, right? So let's talk a little bit about IAM. Did anyone actually watch any of the materials? I mean, I was kind of concerned that maybe there was too many, but then again, I was like, I'll find out. I'll float some stuff by, and I had to spend time watching them at double speed too. So none of them were super long. They just had various bits and pieces of information. Now, part of the reason that I'm giving you videos is because it provides an alternative to what I'm doing here, which is I'm sitting here giving you a live lecture. Those are people who are giving you a structured lecture on video. I don't know about you, but I have a hard time staying awake for video. It's just something about the medium. Being in person is a little bit different than that. But a lot of times you're going to need to have that kind of information. If you're using Gemini, you can actually have Gemini take YouTube videos and it will give you a breakdown of what the video is about. Quite useful. So you don't even have to watch it. You can just read it's not just the transcript. It actually will answer questions. So it shows you the transcript and then it will answer questions about them. So the login part of IAM is where you establish who you are, your identity. The way that we establish who you are is through the authentication process. So in other words, authentication is how you establish your identity. Lots of things actually have identity. This is why it turns out this is a little more complicated than you might think it is, because when you create a service that's talking to another service, that service will typically have its own identity. And you will be able to control it based on that identity. And the reason this is important is because now, once we have an identity, we have an authentication. He's talking about JWTs. Java Web Tokens are a way of establishing identity. It's supposed to be more secure than sending a password in the clear. And honestly, it's not really radically different. You need to use encrypted channels because if somebody gets your Java Web Token, they can use it. How many of you have ever interacted with a Java Web Token, a JWT file? What did you use it for?
To authenticate.
To authenticate. What were you authenticating?
The actions that I was doing in my app, they're able to do certain things. Can you click this button or not? They go in there.
So one way you can use them is to use an authentication channel, establish your identity, and then store this in a way that you can provide it to not require that you log in over and over again. That's really one of the primary uses of JWTs. So for example, I built a whole series of tools that would go off to different cloud providers, and you authenticate once, and then I could basically run the tools over and over again to extract information from the cloud providers. This was storage information. The actual authentication mechanism was a login. Then you would get a token back, and that token would have a finite lifetime. And when that lifetime expired, you'd actually have to go and get another token. So the whole refresh mechanism. And those refreshes are much shorter than when we make you log in. So I've noticed that one of the email services I use now forces me to log in every 90 days. And if I'm using Canvas, I can be logged in for a while, and then it will just decide I have to log in again. That happened recently. Somebody said they weren't able to submit something on Canvas. I don't remember which class it was for. And it took me a minute to figure out what happened, but I was able to reproduce it, which was, oh, look, I have a Canvas page that's been open for many days as well, and I can't edit the page. So, and it didn't tell me that it had expired, so I had to actually go and I had to actually refresh the whole site, and then it made me log in, and then I did that, and then I could see the page again. So that's one of those interesting instances where we have a transient or temporary authentication token of some sort that expires, and then we have to renew it. How many of you know what a cookie is in terms of the web technologies? What is a cookie? It's tasty and yummy, right?
It's like data stored on your browser.
It's actually not on your browser. It is stored by your browser, but it's actually stored on disk or on storage, since no one actually uses disks anymore, which isn't true either. But in the cloud, they use a lot of disks. Cookies, I'm going to step back here. Since 317 isn't a requirement for this, I'm not assuming that everyone has taken networking. How many of you actually have taken networking? So you can take a nap. In computer networking, we have these layers of communications infrastructure that take messages and deliver them between two computers. The specific way that we send messages back and forth is typically called a protocol. And we have families of protocols. And what we tend to do is we tend to build up message streams by encapsulating one protocol inside of another protocol, inside another protocol, inside another protocol. And it's just, protocols all the way down. The most commonly used protocol at this point on the internet is, I'm going to reach here and say HTTPS. Anybody know what the difference is between HTTP and HTTPS?
I think it has something to do with encryption because the S stands for secure.
Right. In fact, it's exactly the same protocol that goes over it, which is the HTTP protocol, the Hypertext Transport Protocol. But the S version goes over a different TCP port, and that port is expected to be encrypted using something called transport TLS, transport something something. Transport level security, that's it. Acronyms, there's so many of them. They're so easy to forget. It used to be called SSL, Secure Sockets Layer, and then they decided to rename it and call it Transport Layer Security. It's the same exact, well, it's the same conceptual thing. So the distinction is that when I send a message over HTTP, that's usually on TCP port 80, it's not encrypted. It's like sending your password in the clear, because you're sending your password in the clear. The benefit of using an SSL or TLS connection is that the actual communications channel is encrypted. Your computer talking to a website uses the certificate on that website to send encrypted messages. And the other side then sends them back. or sends encrypted messages back to you using your certificate, which you've provided to it. This is based on an area of cryptography called zero knowledge proof, public key cryptography. These are, anybody taken a security class at all? Know anything about cryptography? I know way too much about cryptography, so I'm going to be really careful here. Public key cryptography is the idea that you can encrypt a message using a key that is publicly available, but you cannot decrypt that message using that key. It's called an asymmetric encryption protocol. But the funny little thing about that is that, in fact, we don't actually use the public key part of it very often. What we use the public key part for is to encrypt a cheaper symmetric cipher. So we encrypt the decryption key and also the encryption key. We encrypt that, and we send that across in the initial handshake. So we're setting up the connection, and I say, I'm talking to a web server. I pull its public certificate. I use that to negotiate a private key to use for our exchange. And now we can run a communications channel over that, knowing that it's secret, but also knowing that either party can actually read it. That's what you have to use when you start talking about these kinds of authentication steps. It's really easy to actually build one of those public certificates now. For a long time, it wasn't. One of the examples that I actually used last term was this, the Electronic Frontier Foundation, EFF, actually sponsored a system by which you could get website certificates without cost, called Let's Encrypt. And Let's Encrypt has made a huge difference, because prior to that, one of the key business models for making money on websites was to sell people public keys. Now, I have to tell you that the manufacturing cost of public keys is not very high, but they're expensive to buy. They used to sell for $100, and it'd be good for a year. So somebody was literally producing something that cost them less than a penny to produce and charging you $100 for it. Welcome to the cloud. I might have mentioned this. Does anybody know what the average profitability is of a software as a service on the cloud, a business, a SaaS business? So if they get $1 worth of revenue, how much of it is profit?
You mentioned last time it was 80.
Yeah, it's between 60 and 80%. So I usually say about 70%. Well, it turns out that making those certificates way higher than 80%. It's astonishing how profitable this stuff is. But this is important because it helps us secure our systems. So the fact that we can now get these certificates and use them for free, this is great. This actually means that we have noticed this huge use of SSL on the networks, on the internet. Authentication isn't the same as encryption. It's not the same as data security. Authentication is, how do I know you are who you say you are? And a password is one way of achieving that. Increasingly, what's happening now is we end up with passkeys, where the passkeys are kind of like passwords, but they're instead encrypted by something other than a password. So you don't type a magic password in, or you don't use a piece of password software. It generates a passkey in combination with the other site. And you can use things like your facial recognition and whatnot to ensure that your identity is properly properly processed. So once we know who you are, then there's a separate issue of what you can do with that. What are you allowed to do? This is where we get into authorization. This gets into the much deeper issue around permissions models. And so the idea behind permissions models is this is what I'm allowed to access. This is what I'm allowed to do. You might have read-only access to something, for instance. You might have the ability to write to it. You can make these very fine-grained permissions. So you might not have the right to delete something. You might only have the right to insert something. Insert only is very interesting because it means, in essence, it's hard for you to delete things. It allows us to ensure that information isn't destroyed. So what do we worry about? We worry about people stealing our data. We worry about people destroying our data. If you're trying to pull off fraud, deleting evidence or information that indicates what you did is one way of covering your tracks. So we might not permit that. So everything that comes into security, into permissions models, can be quite complicated. And the worst part about it is that the debuggability model here is, sorry, it didn't work. What do you mean it didn't work? Why? What went wrong? Why didn't it work? I can't tell you that, because if I told you that, then you might know how to figure out how to break into the system. What? Yeah. So every 400 error turns into 404 now. Access denied. Debugging security problems is really hard. And of course, the tendency is, if it's in your way and you have a deadline and you're trying to get something done, what do? Come on, you can say it. I can see smiles on faces. Oh, yeah, I know what I do. You turn it off. You just give yourself every permission there is on the face of the planet. What is the danger with this in the cloud in particular?
Someone gains access.
Yeah, all we have to do is compromise your account or your credentials or your machine, and now we've got complete control. This is what's going on with CloudBot, in fact. CloudBot is this basic experimental project that somebody put together, stuck up on GitHub, and now has like 70,000 stars, and people are downloading it and installing it like crazy because it's basically this agentic AI thing that the guy's built a whole memory system around it. It takes remote commands and has no security. What could possibly go wrong with this? Hey, I'm going to hook up my bank accounts and my email and everything I've got in my electronic life to this thing. I wish I was making this up. To this thing that sits on the internet and lets anybody talk to it. I think he actually does have some very basic model of authentication controls, but by default, nah, sorry. If you want to have nightmares about this sort of stuff, there is this website, shodan.io. It is a website that just constantly scans the internet looking for things that people have hanging out there. And you can go and you can take your own IP address at home, you can type it in there, and it will tell you everything that can be seen from the public internet. Like, it will see whatever your router is. It will tell you what brand it is and tell you what version of software it's running, because those are pieces of information that it knows how to get. So I'm not making this up. I'm not trying to tell you that everything will be fine. You just don't have to really worry about the security stuff. I would say that, in fact, I'm telling you the opposite, which is the internet is an extraordinarily hostile place where people are constantly trying to hit you. So this is an area where you do not want to turn off security. If you're going to do that, there are ways of doing it. The first thing you do is you lock down access. You use a virtual private network, and all of the cloud providers can you can build things that basically operate as if they're inside of your own network using a VPN to the cloud service. And that's going to be the kind of thing you're going to want for testing. Speaking of testing, continuous integration, continuous deployment. So this is a common testing paradigm that is used in software development. It's also used in DevOps. So the people who actually deploy this stuff live. How many of you have ever done any DevOps work? If you do, odds are you will probably end up on something called PagerDuty, because that's what happens when you work for companies that have deployment direct to the forward-facing, the external-facing service. And you might think this sounds kind of crazy. Well, what do you mean? Don't you test this software before you push it out? Of course you test this software before you push it out, but your test facility isn't capable of mimicking what your customer base actually looks like, what your actual usage case looks like. And so in the end, no matter how well you test it, it's going to be a minuscule amount of what you're actually going to end up deploying. So these kinds of live deployment models end up being very real. And CI/CD is one of the ways that we use for example, they'll start doing partial deployments. They'll take a new piece of technology and then they'll roll it out to a few customers and they'll make sure it works. And then they'll increase that and they make sure it works. And so that can get quite deep. But the kind of usage I'm talking about here is the one you're probably going to get started with, which is what you want is something that automatically runs and tests your software when you submit it. If you use the actual GitHub, github.com, they have CI/CD. They have actions, GitHub Actions. When I was setting up the repo here, I actually asked the CS people if they had a GitHub Enterprise with actions. They don't, but they're actually testing one now. So there is hope that some future version of this class will be able to actually use that. They gave me an account on the what is it? It's a dev.students, github.dev.students.cs.ubc.ca, because you just add one more name in the middle. And I haven't had a chance to play with that yet, but my plan was to play with that because I think that having people in the cloud computing class setting up to do CI/CD would be great, because this would be the norm for what you would actually build in the real world. These things will run automatically. They'll test your code against a set of test suites that you define. If you're using GitHub, it'll run code reviews of your code automatically using AI. Shared responsibility model. Well, that's a complicated one because often these service models are many different distinct components and you are managing access across them. So you often end up worrying about integrating with different services that have different access control models. So, who are you? Prove it to me, and here's what you're allowed to do. Now, usually this comes from different sources. Who are you? That's your username, your email address, whatever we're using. Authentication is going to be your password or your face imprint or your thumbprint, or maybe we'll draw blood from you and see if you're still alive. I've actually worked with people that were in facilities where the fingerprint readers would actually measure galvanic skin response to see if you were in distress. Is there somebody with a gun to your head threatening you to open a door? And if it is, well, then you're dead, because it won't open the door.
So if you're late to work and you're stressed, you can get in.
Okay, the same group that I was talking about had also been trained in how to detect when they were being followed and how to not lose people. Because when you are being followed, it turns out you probably don't want to lose them. You want to report it so that they can then follow the followers. There's a level of paranoia there. Yeah. You do this long enough, you get to run into people who are in very interesting parts of this business. That one of the facilities I taught at was literally a governmental facility where no one had names on their badges. It was just a 6-character identifier, 3 letters, 3 numbers, and a picture. It was always fun, at least I had name tags. I could say, so November X-ray Charlie 375. What do you think about that? because that's what it said on their badge. And as I mentioned before, the cloud twist is that many times what we're doing is actually using authentication about services, not users. So when you have a Lambda, serverless AWS thingy, and Azure has a similar one, as does Google, you need to make sure that that Lambda is given permission to read from S3. So now what we actually have is we have an access control issue, so that's our authorization. We are allowed to do something against S3. We need something that says, this is who you are. This is my magic S3, or my magic Lambda that accesses my S3. Your continuous integration pipeline also will need to have these kinds of things. When you set up GitHub Actions, you give it keys. It has there's a whole section for GitHub secrets. You're like, I don't know, AI lingerie or something? But no, just kidding. And that's where you're going to be putting PATs, some sort of token that goes in there. Kind of like your JWTs. Least privilege is, in fact, one of the kinds of things that you would test as a claim. So you're going to say, what am I claiming? I promised somebody something. I said, this is going to use least privilege. What does that mean? Well, that means that this service can only access the resources it needs. This is lovely. I love that. So in fact, this is a fun one because how do you build the test for that? How do you make sure that you haven't granted something it doesn't need? You're going to have to actually think about that. You're going to say, I need to verify that it can't do anything that it doesn't need to do. Well, that's kind of an infinite list. So it may not be practical to do that. You may end up saying, here are the things I can test. And that's kind of the point here. If you're claiming something this broad, you may need to think about the fact that there's an awful lot of tests I have to write. Let's say there are 35 different bits that I can use for privileges that can be granted. Does 35 bits sound like a lot? Many years ago, I interviewed a guy who actually had worked on a crazy secure system. And he had done the security design for it, and they had 1 million bits for access control. And he was saying that they had logging inside of this system. It was an operating system, actually. He had the logging inside of this operating system, and when they turned on all the logging and they started booting the computer and watched all of the checks it did, they gave up after a week and it hadn't finished booting. Yeah. That was a crazy, crazy story. But so 35 isn't an unreasonable number. 1 million, that's a lot. So how would you test some of these things? So if you don't need write, you say, I try to write, it gets refused. I try to write to someplace else other than the bucket that I'm authorizing it, it gets refused. But that list could potentially be long. So you have to think about, how do I want to do that? How do I want to demonstrate this? So, traditional CI/CD pipeline. Code it, build it, test it, deploy it. Now, the nice thing about GitHub Actions is you can actually build them and model them and test them locally as long as you have Docker containers. There's a whole package that you can run locally that simulates GitHub Actions. So that makes it really easy to debug, well, easier to debug. It's really hard to debug them when they're on GitHub and things go wrong. It's a lot easier when you can do it locally. So anybody can automate. The real question is, what tests have to pass? This is where the hard work comes in, not building the automation pipeline, because you can build the automation pipeline. You can put 2 tests in there. Gee, look, it compiled. I can ship it. That's what Microsoft does with Windows these days, right? We'll test it in production. What tests have to pass? This is why this becomes important. I've been talking about this, the CCT stuff because that really relates to the promises that you're making for your software. But this is all testing. The test becomes the evidence you have that you have actually delivered what you said you were going to deliver. Now, in this particular pipeline, this is really important because once it passes the test, you deploy it. I have a friend who works for OpenTable. And this is exactly what happens. He builds a feature, it runs through the tests, people sign off on it, it gets deployed. And if it breaks things, and sometimes that happens, they have a rollback. So they actually go back to what was there before. I have another friend who works for a US company called Minted that does custom printed things, like, T-shirts and wedding invitations and party favors and whatnot. And he talked about a case one time where he made a change. And it was to something that they looked at. They said, we don't need this code. Nobody's using this code. So they removed the code. And so people signed off on it. And they discovered, $150,000 later, that someone had been using that code. And that now they were no longer using that code. It was costing the company a lot more money to ship something. That was a really interesting one because he's probably about 5 years older than you are now, but he was afraid they were going to fire him. And I have to tell you that those kinds of things will actually happen in real world situations. You will literally, when you start working with the cloud, make mistakes that can cost $100,000. We try not to do that. So this is the other dark part of the cloud, is the cloud makes it really easy to accidentally spend money that you didn't even know you were spending. Everything is lubricated. It's very easy. There's no friction. It just works. So this is why this kind of testing is important. And when things break, it's generally something you can go back and you can say, well, we should have tested that. We should have tested that differently. We should have looked for something else. But often you don't realize what you should test for until you've seen the failure. Now, how many failures have you actually seen so far when it comes to the cloud? Probably not a lot. Maybe some, maybe none. How many did you experience just to get your Hello Cloud function working? Maybe none. Maybe you got it out, this is easy, no problem. I used one of the tutorials, it just worked. Great. I guarantee that as you continue to work with the cloud, what will happen is you will get hit with these things. So this is going to be interesting, and I was concerned about this when I was going through the slides yesterday. I fixed that. Why is that not fixed? Ugh. Okay. Did I rebuild the slide? I don't think I rebuilt the slide. So, as you start building your capstone project, one of the things that's going to happen is you're going to be making assumptions. And the challenge that I'm giving you is to pick something that you assume and see what happens to your design when we find something that will break it. And we say, what do you need to change in order to address this change? Is this realistic? How many times have you built a piece of software only to realize you needed to do something different? And you had to rewrite the software? Anybody, ever? You guys just write software that works first time out. As your projects become more complicated, this kind of thing is going to happen more often. You are going to find that something you designed for is no longer true. And now you have to step back and you have to say, whoa, how does this affect my design? What I'm trying to get you to do now is to say, how many of you are far enough to actually have anything that is a capstone that could have a design assumption? One person. So what are you assuming in your design?
So right now in my design,
So you guys are all behind now except for him, so no pressure.
I said in order for my application to work, I might use 3 AWS service, Secret Manager, Parameter Store, and CloudWatch. CloudWatch for the logs, Secret Manager for private keys, and then Parameter Store for the public keys to track the version. But I'm not sure.
Okay, great. We're going to stop right there. Can somebody suggest to me an assumption that you could change that would require a redesign here? Because as soon as he mentioned it, I came up with one. Very easy one.
I guess like the secret keys need to be stored like elsewhere, like not on AWS.
Okay, that would be an interesting question. What happens to the design when you move the requirement, the secret keys, so that they have to be stored someplace else? Anything? I mean, you're hinting in a direction that I had thought of immediately as he was describing this, but I'm curious if anybody else will see it. What cloud providers are people using?
I'm using Azure.
You're using
Azure.
Azure. Okay, so he's using Azure. So that was, in fact, what I thought. As you described it, I said, what happens if I change the assumption that I'm not using AWS, I'm using Microsoft Azure instead? Now go think about your design. This is going to force you to say, oh, wow, you know, I hadn't really thought of it that way. Now, do they have some drop-in replacement? Probably. But that's the kind of thing that I want you to be thinking about as you're building your project, especially when you start looking at other people's designs and saying, okay, well, this week, Google has a 2-for-1 sale, so I can actually get twice as many services for half as much. So I want to design for GCP instead of AWS. Or maybe you're a freelance developer and your client says, well, we're an Oracle shop. You're going to have to use the Oracle Cloud provider services. And now you're off looking at Oracle. So that's one way you could do a constraint flip. It's not the only way. It's one way. Let's see. So parameter server for public keys, secrets for private, and CloudWatch. What are you protecting with the keys?
I'll be logging in using the API gateway
Okay, but what are you logging into?
into my safe JWT.
Ah, this is the safe JWT. Okay, this is the JWT thing. So he's logging into a safe JWT store where your JWT is being stored. Where?
It should be inside a Lambda.
Lambdas don't have persistent storage. You'd have to actually store a JWT someplace else, right? You could process the JWT inside the Lambda, but you wouldn't store it in the Lambda. I mean, unless you're hard coding it, and that would seem to be a bad idea.
I think probably right now it's Secret Manager.
Okay, so you're going to have one JWT.
Yes.
What is the JWT for? I'm trying to understand the problem that you're solving now.
Yeah. So my service is it will wrap a JSON web token and then enforce currently, since I'm working alone, 3 things. Key type separation, never read any algorithm from a token header.
Mm-hmm.
And those are the only 2 I will start working on.
Who uses this?
Probably anyone that wants to work with backend development and needs to implement JWT authentication.
So what is the benefit of this over the existing JWT authentication?
If a developer try to use the JSON web token library, all of these things that I'm enforcing are not enforced. It's left optional because the library wants to keep it open-ended. But in my case,
So you're providing this as a lockdown.
I'm not sure what lockdown is, but just a validation service.
You're giving this to someone who wants to lock down their use of JWT tokens.
Yes.
What problem are you solving?
Just checking for.
Why would somebody give you money?
So they don't have to research about web security attack patterns.
What's the problem with this analysis? And don't get me wrong, what is the problem with this analysis? What is the cloud about? I won't tell you. What is the cloud about?
Money.
Right. Why do people build stuff that uses the cloud? Not because they want to donate more money to Amazon, the poor, starving company that it is. Why did Amazon build Amazon Web Services in the first place?
Make money.
Well, they were losing an awful lot of money at that point in time, so they had to make money on something. Does anybody know why AWS exists at all?
I guess because like it's much cheaper than like having to buy your own hardware and have like an on-premise setup.
That's a tough one to argue with Amazon because they're buying their own hardware. Does anybody know? What does Amazon, from a business perspective, what does Amazon offer? Do you know what they got started offering?
Books.
Yeah. Physical objects, books, and they had to sell these things. And what they needed, it turned out, was a lot of IT infrastructure. So they ended up building AWS for IT infrastructure to satisfy their own needs initially. And then they said, we could sell this to other people. And so they started selling it to other people. Does anyone know if AWS makes a profit? Turns out it makes a lot more money than selling books does. I mean, Amazon sells everything now. But AWS emerged because it solved problems they had in their business. And this is not going to change. It hasn't changed. The reason that people use Amazon Web Services is because it solves a problem for their business. By solving a problem for their business, they have a greater opportunity to sell products, sell services, provide additional offerings. Has anyone ever heard of a company called Netflix? What does Netflix sell? Nothing. Does anyone know how Netflix got started?
Didn't they mail movies or something?
They mailed
Yeah.
physical DVDs to you. You would subscribe to Netflix. You'd pay a monthly fee, and they would send you DVDs, and then you sent them back, and they would send you more DVDs because you just picked and choose. And then they said, gee, maybe we could stream these things. And what's weird is that I never talked to Netflix about this, but I talked to Blockbuster. Anybody remember Blockbuster? What did Blockbuster sell? Well, they did actually sell DVDs. Used ones even. It was the same business model. It was just that they had stores, and you would go to the store, and you'd pick up DVDs, and you'd take them home, and you'd watch them. And my God, it must be 25 or 30 years ago now. It was a long time ago. I remember talking to people at Blockbuster about streaming movies home. And they chose not to do it because it would destroy their DVD business. Netflix decided that that was okay. I think Netflix actually officially ended the DVD by mail delivery service last year. It's kind of amazing how things die slowly. Do any of you live in a household with a landline phone? couple people, right? Yeah, it's like, you know, you gotta have something to ignore. There still exist these things called party lines where multiple people share the same actual phone line. You have to pick up the phone and listen and see if someone else is using it, and if they are, then you put it back down. Because it's not somebody in your household, it's somebody in your neighborhood. And they still exist today. Technology actually doesn't displace very fast, much slower than you think it is. But Amazon came along and they said, hey, we can actually offer you the ability to store things on our servers and deliver them. And Netflix said, this could be pretty cool. We could actually build a streaming video business by using AWS. And Netflix built one of the largest distribution platforms of real-time streaming, real-time streaming movie content, all on AWS. They didn't do it because they wanted to give Amazon lots of money. They did it because they were going to make money off of it. And so that's my point. This is why I was asking him, what problem does it solve? Because when you start looking at how you're going to use the cloud, people are using the cloud to solve problems. The idea behind a good capstone is it solves a problem. So you need to be able to articulate. Think of this as the Shark Tank, that you're going to the Shark Tank and you're trying to convince them why they should invest in your company. What business problem do you solve? Like it or not, when you go work for a company, that's what the company's going to be thinking. How are we going to make money from this? Your job is to try and deliver maximum value from the cloud for a minimum cost. And I'm mentioning this because I know a lot of people are still trying to figure out what they want to do for capstones. A good motivation for a capstone is something you think that could be a successful SaaS business or could be a successful B2B business. So something that you could actually sell to someone else and make money at. Construction services. So you're thinking, you know, well, how can we do that? And I'm sitting here thinking, gee, how could we actually get information from all of these people and then sell it back to them? Does anybody rent property here, like an apartment or a tent spot in Stanley Park or something? Right. So here's one of the interesting things that people do. They collect pricing data. And they use that pricing data to establish what the market will bear. Have you ever heard of Instacart? What is Instacart's business model? It's not what you think it is. What do you think Instacart's business model is?
I would assume delivery service.
Right. They're a grocery delivery service. You know what they really are? They're really a price optimization service for grocery stores. So what they do is they constantly test to see what consumers are willing to pay for products that are in the stores. Have you ever seen those stores that have the electronic pricing on them now? Some of the bigger stores have them. The little stores still put physical prices, but the bigger ones, they actually have them. Those electronic pricing modules, they can dynamically change the price. They literally will change the price and compare it across stores, across regions, and determine how much they can get away with charging for different things. So what's really happening is their business is in determining what consumers are willing to pay for products, not based upon what the profit margins are, but based upon what they can maximize the profit on this particular item is. So, you know, it's the whole idea behind, on a hot day, ice cream is more expensive than it is now. Maybe after a hockey riot, the price of ice cream goes up too. I don't know. Because you're sad and you eat ice cream when you're sad or something. I don't know. But what I do know is these are the kinds of businesses that use the cloud extensively because they are solving a problem. And the problem there is, how do I maximize my profit? in this particular business, in this particular line of business. So try and think about those sorts of things as you're thinking through your capstone project. And I'm going to be pushing and having the TAs push on asking you these kinds of constraint flip questions to say, what are you going to do in your design if you change this around? And the purpose isn't to torture you. The purpose is to get you to think about how much of what you're doing is locked into a particular vendor versus solving a more general problem. So, yeah, I didn't think anybody would do this, even when I was looking at these yesterday, going, well, we'll just wing it. So what happens when your system suddenly gets successful and you have 100 times as many users? What happens when you have a customer who now has a requirement about data residency? How is that going to affect your design? What happens when you're told that your budget is 100% over, so you can only get half of what you've estimated here? How is that going to affect your design? One of the things that I've said is, it ended up being forced last term, but I found it was very interesting. It really helped people focus on something that was tangible and easy to measure, and that was, how do you stay under free tier? A variation of that is, how do you stay under free tier until you have a monetization model that allows you to pay Amazon or Google or Microsoft or Oracle or IBM money for their cloud services? How many of you have a free tier account? I mean, you might as well, right? It doesn't cost anything yet. Have you gone over the free tier yet? What happens when you have an SLA suddenly you have to achieve? How do you guarantee availability? Now, in 4.16, I'm off teaching people how to build these services that have high availability so that people like this class can just simply say, I just have to pay for it. And they'll deal with all the details. And that is, in fact, the right model here. The model here is you need to be able to say, when that happens, when someone comes along and is willing to pay the price necessary for me to provide them with 4 nines or 5 nines SLAs, I know how to get that. But that becomes an exercise in design. How am I going to get that? What do I have to do? Where are the sensitive points in my design that will break and that I have to be able to handle? What happens when the data that you're handling suddenly becomes sensitive? Health data is considered to be very sensitive. Are any of you old enough to remember the pandemic? Here at UBC, they actually required that you upload your COVID vaccination record to a third-party service. You know what I did when I saw that? I went and looked at the third-party service. I said, who do they have involved in information security as part of the company? And you know what? You'll be shocked, right? Who do you think they had? Some world-class expert on information security, right? No one. No one at all. Everyone who sat on that C-suite was a doctor or a medical practitioner. No one knew anything about data security. I actually refused to provide it to UBC. They told me that I had to provide it. I said, no, I don't. I said, I will provide it to UBC, but I am not uploading it to a third-party service. I read their terms of service. Their terms of service pretty much said that I was indemnifying them if my information was compromised. So I'm like, I'm not paying your legal bills because you have no IT people. So I did eventually give the information to UBC, who might have uploaded it to that third-party service. But then the liability would have been on UBC's part, not mine. And since I've already been party to a lawsuit against UBC for disclosing my personal medical information, I'm a little more sensitive than probably most of you are. It's the only class action lawsuit I've ever been part of where it was material. It's like $4,000. It's like, that's almost a spendable amount of money. Can't buy RAM with that these days, though. Too expensive. What happens if your team changes? Let's say, you've got a team, and these guys are, these people are great. You say, I want to work with these 4 other people. I've got my team of 5. It's all set up. We're going to tackle this whole thing in the world. And then the day before the actual team thing is due, they say, I can't do this. I'm out of here. What are you going to do? How's your design going to change? Or the reverse, which is your design is going really well, and you're like, wow, there's all these things I could do if I had more people, but I'm just working on my own, and the 4 people who just bailed said, we want to come work with you. How does that change your design? What is the purpose of that? Why am I saying do these things? And the reason I'm saying that is because when you design, what I want you to realize is what you design will depend very much upon the assumptions that you're making. You probably don't even realize you're making those assumptions, and I want you to be revisiting them. I want you to step back and say, what if? How would this affect me? Oh, wow, I hadn't thought of this. Because that's the skill set I want you to leave UBC with. Anybody can write code now. Well, as long as their name is Claude. If you're desperate, you can use Gemini or ChatGPT. You can use Kimi, or you can use GLM 3.5 or whatever. I don't know, 3.2. There's all these different models. They're writing code now, and Karpathy is sitting there saying that sometime in December he noticed that there was this shift. And yeah, the shift was when Opus 4.5 became the default coding model, and suddenly you're like, this is better. It's not going to get worse. It's going to get better. Yeah.
Do you have a recommendation of which AI potentially we should use if you want to do coding? Because there's so many to choose from. Dakota or Cloud App.
Okay, this is a shifting landscape, and one of the reasons that I'm not telling you what to use is because the shifting landscape is shifting, and what I tell you today could very well be wrong next week. But right now, and it's looking, nothing's showing that it's going to change in the short term. That is, Claude is actually the winner right now.
Claude.
Yeah. Claude Opus 4.5 is definitely at the top of its game. But if you have budgetary restrictions, or so you can't spend anything on it, you need to use a free service, then you'll probably want to try and do something hosted on your local machine, or what is it, the GLM, I think you can get a $3 a month kind of program. So there are a lot of options out there, and there's a lot of people who talk about these options, and I have not tried every one of them. I've been playing with Claude and Gemini and ChatGPT now for a long time. And I've given up on using Gemini for code, for now. I barely use ChatGPT for it, for now. And I mostly find myself using Claude right at the moment.
A good strategy would be to use multiple, but then if you're skeptical about a certain AI's response, give it to another AI, and that AI will feed all the wrong things in the response. It'll point it out pretty good. So it's good at identifying the mistakes of other AIs, but it doesn't know its own mistakes.
It's kind of like humans. When you read your own code, you don't see the bugs you put into it. You think, this is beautiful code. Perfect. I cannot imagine doing anything better than this. And then you hand it to the person next to you, and they look at it and they go, what the fuck were you thinking? This is bad code. Right. Yes, and you can in fact do ensemble programming, but there is some evidence that suggests that it doesn't work as well as you think it does. But it's a shifting landscape. That's the problem I have with it right now. But it is also so fast moving that even 6 months ago, what it was doing is way less than what it is doing now. It is very, very fast, very difficult to predict.
You're talking about the pro version, right?
Any of the paid for Claude?
Yeah, for Claude, the free one. Does that cover it?
I think you can use Claude. I think you can use Opus with GitHub. So if you have your GitHub account, you can also use the AI coding that way. One of the reasons that I I made sure that that was available. I think I told people, make sure you get your free student GitHub account because it does include the use of AI because I want to get you hooked. Hey, look, kid, try this. If you are good at what you know how to, if you look around, you will find that there are very inexpensive options. You're sitting here on a Mac, right? So you got a Mac, I don't know, maybe it's a little bit older Mac, but it's still a Mac, and so therefore you've got a GPU that can run local models as well. And you can get decent code, not spectacular, but decent code out of a local model. I mean, I don't know if his Mac is older or newer, I can't tell just by looking at the Apple on the back. But, sorry?
It's old. M1.
There you go, ancient history. It's not M5, I mean, it's like, why are you bothering me? I don't know, and who's got a new Mac? There's a lot of Macs in here.
I got an M3. Or M4.
It's so yesterday.
Yeah.
Just kidding, I don't care. I don't know, what is the current? I think I was reading there's now an M5. But don't hold me to that. At any rate, the point is there are lots of different options. You don't have to use cloud-based systems to do this. You can. There are free options. OpenAI, last I checked, these things do change. OpenAI, last I checked, actually had a free million token. So you could get 1 million tokens free a month. You just had to let them use the data that you give it for training. And I'm kind of like, okay, that's cool. You want to take like my crappy student code and use it for your training, go for it. Whatever, right? It keeps changing is the real answer. You can get Grok, you can get Kimi, you can get Gemini, you can get OpenAI. I'm assuming Claude has a free tier as well. You can get all of these things to kind of do some code free tier, but you're going to spend a lot more time doing it. I don't think UBC is offering anything there right now. The best thing you're going to get for that is going to be GitHub Copilot.
What if we like pull our resources and get like an enterprise account? It'll be cheaper.
It could be.
I think Gemini did like a year for free for students.
There you go. It's probably got limits on it, but yeah.
Yeah, it was pretty good, honestly. I was wondering why you're not a fan of Gemini.
Might have been the $3,500 bill. It ran up overnight on me.
Overnight on.
Yeah, it got into a loop.
Okay.
And I got a notification at 11 p.m. that my $500 budget had been exceeded, and then at 5 a.m. I got one that said that from my credit card company saying that it had been charged another $2,000.
Were you able to get your money back?
No. And it generated absolutely nothing useful. Absolutely nothing. So I was a lot more careful after that, but I don't know. It's one of those things that I will probably go back and try again at some point, but for the moment, there are things I like Gemini for, which like long context things where you can throw huge documents at it and you can get something useful out of it. But in terms of coding right now, I've been sticking with Claude and I haven't really looked elsewhere. I might poke around a little bit. Another approach to that is just to use APIs, or you can use Cursor. So there are lots of services there that you can use. The OpenRouter approach is an interesting one because OpenRouter almost always has at least a few different models that are free. They're free API tokens, but that means that it's free for whatever's being tested this week. So literally the providers will put models they're testing out on OpenRouter and list them as free, and it'll be available for free for like anywhere from a couple of days to a couple of weeks, and then it disappears. So, but some of the models are actually pretty good. I mean, I did run Kimi with OpenRouter. No, I ran Kimi directly, I think. I ran Kimi directly with Cloud Code. So there's an override in Cloud Code that you can point it at a different URL and a different token, and it will just run the Cloud Code framework against an LLM that supports the Cloud API, their Cloud API. Some people like Grok. I haven't used Grok for coding. Just something weird about that. So maybe this is the slide I fixed. So when you do this, state what your assumption is, identify what breaks when that changes, sketch how you would change it, what would you have to redesign, and then think of the trade-off. What are you losing when you accommodate this change in design? This is just a good mental thought experiment or thought practice to say, what am I assuming, what's going to break here? Here, is it here? Oh, gee, only. Okay, we're running short on time because great questions. I definitely appreciate that. So again, more of these kinds of scale. It's just more concrete suggestions about the general kinds of design flips, constraint flips that I was talking about. So you can look at those, think of these as examples. And none of this is happening. I really have to figure out how to get these in-class studios to work better. Constraint flips are really common. Businesses pivot, you get regulation changes, budgets get cut, happens all the time. Well, you got to do twice as much with half as much. And have a nice day. And oh, by the way, you're not getting a raise this year. What? Scale problems happen surprisingly often in this business, where suddenly you get, you get influencered, where some influencer picks up on what you've been doing, and you've been sweating away at this thing, and all of a sudden you get a 10x increase in traffic or a 100x increase in traffic. And one of the things the cloud actually really does do well is scales. If you've designed it properly, if you've thought about what's going to happen. If you don't design it properly, what's going to happen is your credit card's going to get dinged every 3 hours because you've hit your limit and they just keep pulling money off of it. You don't want that. And the solutions that you use at low volume that are often good enough and you don't really care about the cost can become cost prohibitive when you go up in scale. One of the reasons people use serverless is because serverless is scalable and relatively cheap. But serverless also has what's called a high cold start cost. There's nothing running. They have to spin up a container, inject your Lambda into it, or whatever your serverless function is, into that, and run it, and then shut it back down. Now, if you're only running these things occasionally, that's fine. It doesn't really make much difference. When you get to a point where you're doing this frequently, what you then want to do is you want to say, I want the container. And I can inject my own serverless functions into the container. Now the container is warm, but now you're paying to run this thing. So you're trading off different parameters there. There was a really interesting discussion about last time where we were talking about logging data. You were talking about the logging service, right? So when you start collecting logs, they can become astonishingly large, astonishingly fast. Not for your particular project, but in this case it was an audit log for transactions for like a bank. And the numbers of just the sheer volume and what you're going to do in order to try and collect all this stuff was really interesting, because the 1 million transactions a day adds up pretty fast. And you have to think about those things. All right, finally, on Thursday, we're going to actually talk about peer review, about what it's like to review capstone designs. I have 4 sample capstone designs that are actually in Canvas, because I put them up there. They are anonymized. That is the name of the file is the MD5 hash of the file, so you have no idea where they came from. I'm not promising they're really good capstones, but I'm not promising they're really bad ones either. So the idea is just to give you something concrete to look at so we can talk about how to review these sorts of things. And don't forget, biweekly check-in number 2 is not end of class. I fixed that. It's due before class on Thursday. I think I didn't rebuild the slide. That's the problem. 2 different places for them. Yeah?
For the constraints flip reflection, do we just do one with an example, or do we have to come up with the counselor? Like, do we do one on our...
You can just do one in your repo, that's fine. I don't really care. I mean, I'm not super concerned about this one. The idea, though, is that, I'm going to keep saying, put things in the repo because that helps us see what you're doing. How many of you have actually received feedback from TAs yet? You got something? No. Kind of.
But not on textual. More like a picture paper.
It should have actually been in your Git. It should be a Git issue.
Oh no.
All right. I have to ping them then because they've had that stuff for a while now.
So does it actually have to be constraints from our capstone? Whether can it just be?
Just make some up for now, right? Because I know that people aren't far enough ahead. If you have a capstone, by all means use it. If you don't have a capstone, then steal a different capstone.
All right.
You got examples for Thursday anyway, so you've got something to work with if you want.
All right.
Yeah.
Thank you.
Hey, no worries. Figure out how to make this easier. Hey, how are you?
I am well, sir. How are you?
I'm all right. I'm stuck.